Hello, so here we are looking at GCSE Physics for CCEA 2015, and this is Unit 2. Question 5. The diagram below, which is not to scale, represents our solar system, and you can see we've got various parts of it labelled here. A part 1. Name those features of the solar system indicated. Write the names in the boxes. Now firstly, you're going to need a memory mnemonic for the order of the planets, and mine is my very excellent memory just served up 9 planets. Oh, poor Pluto, he's not there anymore. My very excellent memory just served up 9 planets. If you do that, you can then tell which ones are which, because we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto that isn't there anymore because Pluto was relegated to a dwarf planet. It's not counted in the planets anymore. So to get these right, we need to also recognize that there's a zone between Mars and Jupiter with a ring of asteroids. We call that the asteroid belt. So that helps us to fill in these various things. We've got 1 asteroids, 2 here is Neptune, 3 here is going to be Venus, 4 here is going to be Saturn. So as I say, it's a good idea to get yourself a memory mnemonic. So as I say, get yourself a memory mnemonic to get the order of the planets sorted in your head, because here's an example where knowing that order was worth quite a bit. Part 2 then, other than those you have labelled, name 1 rocky and 1 gaseous planet. Okay, so remember that the rocky planets are the near objects to the Sun. So the rocky planets are this first group of 4, and the gaseous planets are this outer group of 4. So you just have to pick something from the unselected. So for rocky, Mercury would do, Earth would do, Mars would do. And for gaseous planets, Jupiter hasn't been used and Uranus hasn't been used. Part 3 then, name the 2 main gases found in our Sun. Now remember, what's going on in the Sun is that hydrogen is being fused to form helium, so they'll be the 2 main gases. And the process by which the energy is being produced is nuclear fusion. B then, what is the difference between the heliocentric and geocentric models of the solar system? Well, remember, heliocentric is a sun-centered and geocentric is earth-centered. Helio is the sun, not the sun. And the geo is the earth. Okay, so heliocentric, the sun's at the centre with all the planets going around it, and the geocentric is the earth at the centre with the planets and the sun going around it. C then, the heliocentric model of the solar system was suggested in an early 17th century when Galileo Galilei used a telescope to observe the planets. At the time, who were the main objectors to this heliocentric model? So that would obviously be the established church at the time. Name 1 observation that could be explained by the heliocentric model but not the geocentric model. Now the most obvious one here would be the retrograde motion of planets, when planets sometimes appear to go backwards across the sky during the year. Part D. Spacecraft have been sent to explore our own solar system. However, If manned space flights are to be used to explore the outer regions of the solar system or beyond it, it will require the use of space stations. Give 2 reasons why this will be the case. Okay, so this is all to do with, I would assume, this is all to do with having to assemble and build the craft themselves in space and load them gradually. Okay, so lifting stuff off directly from the Earth uses way too much fuel. The ship would need to be assembled gradually, and that's pretty much the way the International Space Station has been built. Secondly, the stores and stuff, all the materials that you're going to take with you, they would need to be taken up gradually as well. So the other issue, there'd be very, very long flight times involved, so food and fuel might be a problem. The need to return, for example. And it may be that you need to have materials sent ahead using automated systems to perhaps have them in orbit around the destination, so that all you're going to do is head towards them and meet them at the other end. So, I mean, the answer is supposed to relate to the use of space stations, so we have to be talking really about space stations. I've looked at the CA mark scheme here and it doesn't mention space stations, which is bizarre. Part E, the most widely accepted model for the formation of the universe is that of the Big Bang. Below is a list of statements or events relating to the formation of the universe, but they are not in the correct sequence. Place them in the correct sequence by writing a number 1 first all the way to 4 last in the box beside them. So what have we got here? Well, we've got expansion and cooling, expansion and cooling, expansion and cooling. So there's a lot of expansion and cooling. We need to know which ones are which. Here we have hydrogen nuclei and here we have hydrogen atoms. Now, nuclei would have to form before atoms. So atoms is at a certain point in it. Neutrons and protons have to exist before nuclei can form. So I would basically say that this original rapid expansion and cooling is the start of it all. So I would say that is number 1. 2 is when the neutrons and protons form. Then they can form nuclei, and last of all, hydrogen atoms can form. And that is that. Part F, when astronomers scan the sky, they can detect a radiation which supports the Big Bang theory. What is the name given to this radiation? Okay, so this is the cosmic background. So its correct title is the Cosmic Microwave Background Radiation, the CMBR. Part G, evidence for the expansion of space or the universe comes from the redshift measurements. Explain what redshift means and how it supports the idea that space or the universe is expanding. Okay, so redshift relates to the Doppler effect, and the idea is that we know exactly what the spectrum of light from a star should look like. And when we look at distant galaxies, the spectrum is there, but the lines of the spectrum are in the wrong place. They've been shifted towards the red end. So light from distant galaxies is shifted towards the red end of the visible spectrum. The light has basically had its wavelength stretched, and this can only be because the light source, and in this case the galaxy that the light sources are in, the stars, is moving away from us. So that galaxy must be moving away from us and every other galaxy. And that can only mean that the universe is expanding. And that is what redshift means. Okay, so we've got light coming in from distant galaxies, and it comes from stars, and stars have very specific spectral lines in them that correspond to the presence of the hydrogen and the helium that we've already talked about. Those lines are in the wrong place when we look at distant galaxies. They've been pushed towards the red end, and basically what has happened is that the movement of the galaxy has stretched all the wavelengths. The galaxy must be moving away from us. Okay? And if you think about it more carefully, we're not unique. So actually galaxies are moving away from each other, and that means that the universe must be expanding. Okay, part H then. One model for the future of the universe is that of the Big Freeze. Briefly explain what will happen within the universe should this model prove to be accurate. Okay, so what you've got is you've got the original Big Bang, and the possibility that the gravity will eventually stop the expansion of the universe and it'll close back in on itself over a similar amount of time, and that'll be called a big crunch. However, if gravity isn't strong enough and the universe continues to expand, it will just expand and expand and get colder, and we call that the Big Freeze. Okay, so the universe expands forever. The temperature will drop because the matter and energy that exists in the universe is a fixed amount, and if you spread it out over a bigger and bigger area, then over time that energy will be less and less available in any one area, and so it will just get cooler and cooler and cooler as that material spreads out. And that's what we call the Big Freeze. And that concludes our business with the space question. Thanks for watching.